So in this video, we are going to look at using the power rule, but we're going to find the derivative or slope at a specific point. So the main thing with this is that you always, when you're finding at a specific point, so like when it says, here's my function and I want f prime of 3, or if it says, here's my function, find the derivative at x equals blank. You always take the derivative first and then you plug in the x value. Never plug the x value in first, because then you're making it a constant. And if you take the derivative constant, you will get 0. Okay. And the slope of this is not 0 at x equals 3, or most likely is not. So the key is when you are finding the derivative at a specific x value, you take the derivative with the variable in it first, and then you plug in whatever the x value is. So and if they're asking for the derivative slope, they can ask you in 3 ways. They can say find f prime of a, where this is a value. They can say find the derivative at x equals a, or they might say find the slope at x equals a, and that's also means the derivative. Okay, so for this example, we want to find the derivative. Now, again, a lot of times we have to first use our exponent rules from pre-calculus, and then from there, we can use our power rule. So we want to use our power rule, and our power rule, again, is when we have f of x equals x to the n, we can move the variable to the front, we leave the variable there, and then we can subtract 1. But in order to do that, we have to get it in this format. And anytime we have a root, we can get it in this format. So if you remember, for a root, if it's the 7th root of x, it's x to the first, even though we don't write it. And so when you change a root to an exponent, it becomes the exponent on top, and then the root part goes in the denominator of the fraction for the exponent. So x, the 7th root of x, is like x to the 1/7. They're the same thing. And then when I take the derivative, I use that power rule. So I bring 1/7 to the front. I have x, and then I subtract 1/7 minus 1. Right? And so that gives me 1/7 x. 1 is 7/7. So if you subtract that, you get negative 6/7. And if you were asked to simplify, well, then we would have the 1 in the numerator, the 7's in the denominator, and then the x, the negative 6/7, because it's negative, we can move it to the denominator and make it positive. And if we wanted to leave it as a root, it would be the 7th root of x to the 6th. Okay, so the numerator is always the exponent on the variable, and the denominator is always the index on the root. And so that's how you find the derivative. And then we want, when x equals 3, we want f prime of 3. So this is f prime of x. To find f prime of 3, and now I'm going to plug in 3 to my f prime notation, I'm going to plug that in. So I have 1/7 times the 7th root of 3 to the 6th. So if I do this, I get 1/7 times the 7th root. This gives me 729. And then just for a root, I guess exponent and root. So for an exponent, you use the caret this, and you type in whatever the exponent is. But if you want to do a root, you hit, when it's anything other than the square root or the cube root, you hit the index, which is the root that you want. So I want the 7th root. You go to math, you go down to number 5. So this is the cube root, the square root's on the main key, but if it's any other root, you hit whatever the index is, which is that number you're trying to take the root. And you go down to math number 5, and then you type in the number that you want, 729, and hit enter. And so I get 2.56. This one gives me a decimal. So we might just like leave it like that, or if they wanted an approximation and told you what to round to, then we would multiply that by 7 and then do 1 divided by that answer. Okay, but that's how we find the derivative at a specific point value.